Hello everyone. My name is NETA, and today I'm really excited to talk about how to boost the React Native performance with React Compiler, a sneak peek into the future. But before we dive in, let me ask, how many of you are already using the React Compiler in your projects? One person? Okay. So, as we all know, a lot of performance issues in React Native applications come from components re-rendering more often than they need to. So we spend so much time writing things like use memo, use callback, react to that memo, and if then, sometimes it's easy to forget a dependency or optimize something that didn't even need to be optimized. Over time, this adds complexity, slows us down, and makes maintenance harder as our app grows. So that's why and where the React compiler comes in. It's a new build time tool that brings automatic memorization to our code, optimizing our application. So the React compiler analyzes our component structures and automatically applies memorization techniques to reduce unnecessary re-renders. Unlike manual optimizations, where we have to decide what to memorize, the compiler takes care of it for us. That means that it's now much easier to get optimal performance without any extra effort from our side. The React compiler was first released in beta back in October of 2024 by the React core team, and it's now available as a release candidate. And so now it's no longer experimental. That means that it's stable enough for real-world projects. So the React compiler, what excites me about React compiler is the shift in responsibility, because instead of us developers worrying about every single optimization, the responsibility now moves back into the code itself. And the compiler makes sure it runs in the most efficient way possible. To make this more concrete, I've created a sample project with Expo so we can see how the React compiler behaves in practice. In this code example, you will notice we have state filters and pretty much like any normal application, nothing fancy, just the kind of code we write every day. So let's see auto-memorization in practice. The first step is understanding what's actually re-rendering in our application, so we know that normally we need to optimize. The easiest way is to check with the React Dev tools, and we can see the tab, the profiler tab, and we can enable the highlight updates when components render. As you are seeing now, I am like typing something in the input, and all my screen is re-rendering, even the title or the card component which aren't connected to my input. So now let's see what's needed to prepare our code base for the React compiler. The first step, we need to check compatibility between React Native React compiler and our installed libraries. The second step, and this is optional but highly recommended, is install the ESLint plugin, and because this will help enforce the compiler rules automatically. Yes, I am checking here if the compiler is compatible with my code, and yes, it's compatible. The next, we need to install the compiler itself. Let me copy the command. Sorry. I jumped a moment. So I will talk, okay. The compiler comes as a Babel plugin, and since I am using Expo in this project, we don't have to touch the Babel config manually. If, for example, if I was using the one React project or even a React Native project without Expo, I had to make this configuration manually, but as I am using Expo, I don't need. And I have to install the compiler, and after that, I have to restart my Metro, cleaning the cache, and is all it. I had a bug with that, but okay. Now some pitfalls and compatibility. Like any new technology, the React compiler isn't fully compatible with all the libraries. For example, libraries that use deep proxy-based state management, like MoX, don't work with the compiler at this stage. However, if you are using stores like Zustand, those are already compatible and work perfectly fine. Another good thing is that you can adopt the compiler incrementally, and if you find a page or component that's not behaving well, just add this directive at the top of the component, and that will tell for the React to skip compiler optimizations for that part of your app. So you are always in control of where and when to use it. Now let's take a look at the React compiler playground, my favorite part. Here I can write any React component or code and instantly see how the compiler will optimize it. On the right side, we get the optimized version of our code, and we can enable the internals of the React compiler playground, and we can go deeper and see every step of the compilation process. It shows things like the analyzer, which breaks our function in smaller parts to understand the dependence. We can see the SSA, the static single assignment, which is an intermediate representation that compilers use to track how variables change through the code. And finally, we can see the generated optimized output, where React Compile automatically applies memorization and reuse computations. So this playground is a fantastic way to actually see what the compiler is doing under the hood, and it makes a very complex process much more visual and understandable. So thank you. My name is ILDA, and if you can talk to me, you can scan the QR code, and is that. Thank you.